The Great Wave is iconic. It may even be the most reproduced image in the history of art. And the Fibonacci sequence looks like a bunch of numbers. However, it forms the underlying structure and composition of the Great Wave and many other works of art. It can even be found in nature, like the spirals of a pine cone. Math may seem boring or complicated, but if you could understand it better, then maybe it wouldn't be. Despite the extensive literature on math and on language, mathematical language itself hasn't been widely researched, and there's no standard way of measuring it. You'd think that being good at math language would mean being good at algebra or problem solving, but if there's no way of measuring it, then how can we really know? My research aims to develop a practical way of measuring math language and to examine how math language relates to math performance. Now, typically, researchers use a measure of math vocabulary, and even those tasks vary a lot. The problem is that math language is more than just vocabulary. Look at the Fibonacci example. Symbols and graphs can bring additional information that words alone cannot convey. And it's this integration of words and symbols and graphs that form meaning in math. I developed 4 new tasks to measure math vocabulary, or language. Participants were given 2 items on a computer screen and asked, do these represent the same thing? Yes or no? Pairs were either a word and a definition, a word and a symbol, a word and a graph, or a symbol and a graph. I conducted 2 studies with undergraduates to refine these tasks, and I calculated the difficulty of each item, as well as how it helped discriminate between low and high performance. Because I was also interested in math performance, participants were given multiple choice questions in algebra and problem solving. Now I'm still analyzing the data for my final study, but I can already see that all of my tasks are good predictors for math performance, with the word and symbol matches bringing a little something extra. So what does this mean? Well, we now have a reliable and efficient way of measuring math language, and hopefully, with time, my research will make its way to the classroom. Teaching math language, especially how the words and the symbols are connected, may have important implications for math education. To paraphrase Wittgenstein, the limits of our language mean the limits of our world.